It's a soccer kick. It's kicked at an angle of 37 degrees with a velocity of 20 meters per second. That means its actual velocity, as shown here, is 20 meters per second, and there's its angle. What we need to do first, before we even kind of dig into this, is figure out its x and its y velocity. So let's come over here, and let's look at its x, and let's look at its y. So the velocity in the x, let's draw the triangle. 37 degrees. So we'll go with 3 sig figs for the velocity in the x and the velocity in the y, make our lives a little easier. Okay, so we've got the velocities in the x and the y. What else do we know? That's all we know, except we do know the acceleration is negative 9.8 meters per second squared. That's important. That's really all we know. So A, find the max height reached by the ball. We know the velocity in the y at the max height is 0 meters per second, so that's something to know. And so let's see. Using the equations, I think VF squared equals VI squared plus 2AD works the best. 0 equals 12 squared plus 2 times negative 9.8 D. So then negative 144 is equal to negative 19.6 D. So 7.35 meters above the ground. So find the time the ball travels before it hits the ground. And that we can let's ignore this. So that's the whole parabola. And so what we know about that situation is the D and the Y is 0 meters because it started at this level and it ended at this level. So it has made no displacement overall. So let's see. Probably the D equals VIT plus 1/2 AT squared. Now this is all Y stuff. Put my Y's in here. 0 equals velocity in the Y, which is 12 times time plus 1/2 negative 9.8 T squared. So 2.45 seconds. And that is the time, the total time of the movement. If we wanted to get to the halfway point, we would just cut that time in half. So 2.45 divided by 2, 1, 2, 1, 2, 3. You know, it did have that second question. So then let's see what C says. C asks the horizontal range of the ball. So it wants this dx. Well, we have the Vx. We're looking for dx, and we do have time. So 16 equals dx divided by 2.45. So remember, this is the only equation we can use in the x direction. So 39.2 meters is the dx. Determine the velocity of the max height. Well, at the max height, we know the Vy is 0. And the velocity, the V, equals the Vx. So D, the velocity equals the Vx, which is 16.0 meters per second. So that's the answer to D. What's the velocity just before it hits the ground? Well, it went up at 20, so the velocity, yep. And then if we were to look at the angle, so the x would still be 16 in the forward, the y would now be 12 down, and when we get this angle, it's roughly 37 degrees south of east. So notice it's the exact same as before, it's just the direction is different. So same magnitude, same angle, just the direction. And if you don't have that negative there, that's fine. You just have to know that that the y component is negative. That's the important part. Okay, find the vertical velocity of the ball at a height of 3 meters above the ground. So you're looking for a velocity at 3 meters above the ground. So probably looking at this equation, because it's got a height, it's got initial velocity, and it's got a final velocity. So we can put that 3 in here. So we're looking for this velocity final squared. This is 12 squared. Remember, this is the y direction. Plus 2 times negative 9.8. Rather, the d is 3. So the velocity final squared is 85.2. And the velocity final, and this is in the y, is 9.23 meters per second. So at 3 meters above the ground, that is the velocity in the y. Now, that's on the up. On the other side, same level, down, it's negative 9.23 meters per second. And then G says find the velocity. So it's asking for that total velocity. So for G, what we're looking at, and it said the first one, so we'll use the first one. We know that the Vy is 9.23. The Vx is 16 meters per second. We know that because it is constant. It is not changing. It's always going to be 16. It wants us to find the velocity. So this is the Pythagorean theorem. So V squared equals 16 squared plus 9.23 squared. Let's say it's like 341.1, and then the velocity is 18.5 meters per second. It's very important that you note that it's not above 20. If you get something above 20, you're wrong. Can't get any faster because gravity is slowing it down. So let's find theta. The tan of theta is equal to 9.23 over 16. Therefore, theta is roughly, it's close, 30 degrees. And according to my drawing, it is north of east. And this is for that first one. If it asked for the second one, it would be 30 degrees. But in this case, it would be south of east because it would be below the horizontal. And the way you look at that is 9.23 down while it's still going 16 over.